A quick introduction to myself. I'm Scott Richardson. I'm currently the front-end team lead here at Project Reclass. I started volunteering at Project Reclass about a year ago, and currently separating from the military. And then we'll be joining Facebook later on in this year. So very excited about that. But to go over some of the technologies that we use here at Project Reclass for specifically the front end. We use React and TypeScript on our front end. We use Emotion for our styled components and Shaka for our component library. And one of the two main libraries that I'm going to talk about in the next couple slides is going to be React Flow that we use for our emulator and also Doggraph. So I'm going to talk a little bit about our interactive emulator. So last year, we created our first iteration of our emulator. And if you can see the GIF in the right, we initially had an image that was sent back from our backend server. Now, that image wasn't very customizable. We also couldn't interact with it. And so we wanted a way that we could change the colors of it. We also wanted to get rid of that white background there because it just didn't fit the theme of our application. And we also wanted to be able to click and drag those different nodes like our host, our switch, and our routers. And so whenever we looked to solve these problems, we came across two main libraries, React Diagrams and React Flow. The first one that we looked at was React Diagrams. React Diagrams was a really good option. It was open source, so it was free to use. It was really simple to get started. But some of the main things that we saw was that it lacked good documentation, and it also was not very easily customizable. Our second option that we looked at was React Flow. Some of the pros to React Flow was it had very good documentation, it was customizable, and then it had very good examples for each one of these options that we could do to customize it. But one of the cons that comes with that was that it was more complicated, right? As you get more options, it just inherently gets more complicated. So in the end, we ended up choosing React Flow. And the main reasons why was because the documentation was very good. Basically, everything that we could want, anything that we wanted to change, it was all documented. It all had very good examples. And then the second option, it was very customizable. As you can see, as you saw in our previous demo, we changed the look of our nodes. We changed the look of the connections between each one of the nodes. And we also can change the background. So you can see, this is basically the demo that we saw earlier on the right. But now we can click and drag these nodes. We can also right click and have context menus for each one of our nodes. This is a great step forward from our previous iteration with just an image. So now in the future, we will be able to change the colors. We can also change our context menu. And we can just basically customize this to our heart's desire, which is a very good win for us. And after that, I'm going to pass it back off to Tay to talk about some testing frameworks that we use on the front end.
Thank you so much for the awesome breakdown of why we use React Flow. Like a UI like this was such a dream for us a year ago. So Scott, thank you for joining us for the past year, and I'm so excited for where you're going next at Facebook. Next, we have John speaking on how we pick Cypress as our front-end testing framework. Unfortunately, John was unable to make it today because he lives in South Korea, and we scheduled the event at 3 a.m. his time. So despite being a world away, he did make time for us by recording this video, and I'm going to run it quickly because we are a few minutes behind.
Hi everyone, my name is Sung John. You call me John. I'm a data scientist reclassing into software engineering, and now I'm working for software developer team in Project Reclass. Today, I'll give you a brief overview of the Cypress testing framework and why we use it at Project Reclass. Before Cypress, Toynet used to use Jest Test, a JavaScript library for creating, running, and structuring tests. However, we found some pain points of this Jest test. First of all, it needs a lot of things to import: React, render, wait for, and other things just to get the test working. Jest was made to be simple, but we still find it complicated to use it. And finally, it can only test one component at a time. We wanted to test the relationship of different components. This is why we got interested in Cypress, a front-end testing tool built for modern web applications. Cypress is built as tester-friendly. For example, I don't have to write any awaiting functions. I'll explain this part later. Like Jest, Cypress focuses on simplicity, and I think Cypress got really well with it. Cypress also provides time travel screenshots and videos. You can see on the right, there's a comparison between Jest Test and Cypress. Overall, Jest Test is specialized only in unit tests, while Cypress can test multiple elements. In Jest Test, subcomponents are usually stubbed and tested separately, while in Cypress, we can test the whole app. Here is an example of a Cypress test for Toynet. It checks if the correct number of devices with the correct numbers are rendered. You can define the dimension of the screen using viewport. Localhost 3000 is where Cypress can find the home page. Cypress can find the try it button and click on it to simulate the user's action. I can also check if the certain text like router or R0 exist. We can do even complicated actions such as clicking the router's plus icon buttons 5 times to make 5 more router devices. I tested this below by confirming the router R5 exists, but R6 does not. We also looked into another front-end testing framework, Selenium, a testing framework to validate web application across different browsers. Like Cypress, Selenium works by simulating user actions. Here is a comparison between Cypress and Selenium. While Selenium is required to install all kinds of browser drivers, Cypress is not dependent on front-end framework. While we have to add explicit or implicit in Selenium, Cypress automatically waits for commands. I'm emphasizing this again because I never enjoyed adding those waiting functions. Selenium script and browser driver communicate through JSON wire protocol, very complicated, while Cypress operates within the app. Like this, we didn't go with Selenium because it had these pain points: inconsistent results, complicated process, and no snapshots. This is a Selenium test example. This does the same thing as the Cypress example I've shown earlier. You can see the Selenium test is longer, more complicated, and also requires a lot of things to import, while Cypress does not. Here is a summary of comparing Jest Test, Cypress, and Selenium. Cypress provides the most robust snapshot, including time travel abilities. Selenium and Cypress can automatically test the whole app, while Jest Test is manual and limited to just one component. Most importantly, Cypress automatically waits for commands. No more awaiting functions. Here are some more Cypress tests. These are the before and after screenshot of checking if the devices R0, S1, and H1 already exist in the emulator provider when the user visits the emulator. I have transferred Jest Test to Cypress Test, and Cypress was good as we are testing the app itself. We don't have to define session ID or anything. We just go to the emulator by localhost and the try button, and then check the div that contains R0, S1, and H1. These are the tests for Configure tab. Instead of having to understand the business logic and testing helpful functions, I simply needed to simulate the clicks of the plus icon to check the newest device names, which is more intuitive. The biggest issue I had when working with Cypress is that if there are multiple components with the same ID and no written text, then it is hard to distinguish them. For example, all 3 plus icons in the Configure tab share the same style, so it is hard to find out which one is which. I can access the first one and the last one, but I'm still having trouble testing the switch icon, which is in the middle. I'm currently trying to add a test ID so I can identify which one is which. My other unsolved challenge is that I failed to check the exact location of the scroll bar with Cypress. This is the trouble I had when testing the panel jump bug. There are other possible future works. We can't check React functions such as hooks, so we need a way to check them. Also, we need to rewrite the Cypress tests for Scott's new emulator, which he just presented. And I think that'll be all. Thank you for listening.